Alright, should be recording. I see the file. It's hooked in. Let's go. It's going medieval. Keys provided by Tinsley PR. In some ways, this has actually been a pretty, boring week, hasn't it? At least as far as gaming news and such. Yeah, I only got a few things. Yeah, one I didn't include because I don't... For one thing, it wouldn't play for me. But the other is Twitch doesn't keep its VODs up for long, does it? There's a Kingdom to Come Deliverance 2 dev stream, but it's like, I didn't have information as to what all it was, and it's... I mean, as I said, Twitch, I don't think it keeps them up for a while, and I couldn't even watch it, so... Yeah, didn't really focus... Because it's also, I'd have to watch through the entire thing to actually write up what the hell it was, so... That annoys me. Anyway, But yeah, I mean, we got the reviews coming in for the 9800X3D, so AMD's latest and greatest CPU with 3D V-cache. And I've not looked too deeply, but it does look like it kicks ass at gaming. Like, it's actually really, really powerful there. And they did one thing with it that is actually very interesting. I find that very interesting. This it's a technical thing. But I find it, like, maybe it's because of it being so technical that I find it so interesting. So with the prior X3D CPUs, like the 5800 X3D that's in my test system right now, the processing layer, so the layer that has the CCDs, that's what holds the processing cores in these CPUs, is at the lowest level, so it's directly over the organic substrate. I found a little funny somewhere saying that it's just referring to it as fiberglass. It's like, well, I'm pretty sure that they are organic, meaning it's just, yes, it's fiberglass. It's basically just PCB with everyone's things. There are other types of substrates that are more active, so they actually, like, you could call it passive instead of organic, but are active where they actually have things like boost the signal and such, and maybe even do some processing in there. I don't think... I know that's something that companies want to investigate using, but I don't believe anyone is it. And I, by the way, do not remember what all it is I want to be doing in here. I do know I want them to be cooking up food, so let's actually... Oh, I've got mining really high. Alright, let's bring that down so cooking can be the highest. No, actually, let's turn those up as well. Okay, then that can actually go down. You know, yeah. Unnamed the dog has died. Anyway, but yeah, so like the 5800X3D that I have, and also the 7000 series CPUs, the CCD is the lowest level above the substrate, and then the 3D V-cache is put on top of it. And there's also then a bunch of inert silicon to fill in the rest until it gets to the IHS, the integrated heat spread. Well, apparently they decided that for the 9000 series to change that, when now the 3D V-cache is on the bottom, and the CCDs are on top, or rather just CCD is on top. So now you still have to have silicon because the 3D V-cache is smaller than the thing. So it would be, yeah. There. I will be canceling this later. So it's now kind of like this because the V-cache is smaller. It has a smaller footprint than the compute die that's up here. Well, that's annoying. Anyway, I can't just select and cancel. But anyway, so they have to have silicon, inert silicon filling in here, but they would also have to have through silicon vias, TSVs, which would basically just be copper wires embedded in there that will go from the substrate to the CCD because it has to be able to send messages through, but also get power. And that's actually what makes this so really interesting. Okay, I got it. because by doing this, it brings the main heat producing part. The cache will produce some heat, but not on the level of the CCD. It brings that closer to the IHS, which means then that there's actually going to be easier heat transfer. And this is significant because that means that these CPUs should actually be able to maintain higher frequencies longer, because it can have, you can dump more power and it can just be evacuated out more easily. It really is a neat and clever thing. And I think I also saw it mentioned that they have fully unlocked overclocking compared to the other. So I think that the 7000 series, and I know the 5000 series, they had overclocking locked down. That would in part be because of heat reasons. And I want to say it's also... hang on, actually, I actually have the Tech Power review open. That does list some of the stuff. So yeah, like okay, so they have a list on the first page of all the different CPUs. For the 7000 series, it does show that the like the normal non-3D, non-X3D versions had like TDPs of 170 watts, but the X3D versions had to be down at 120. That would be because the heat going through the cache is inefficient and potentially could cause errors in the cache. But as I recall, oh wait, hang on. The 9800 X3D has a TDP of 120. They do say that the Ryzen 7 9700X is 65 watts, so it would be higher. But what? Okay, that... Let me try looking it up. I don't remember the CPU lineup from AMD at the moment. Okay, I do see... Is it only... That could be the case, that it's only the... Yeah, let me just see the Ryzen processor. I want to see the list. I'm looking at Amazon's website. Not Amazon, AMD's website at the moment. So I just want to see... Here we go. Oh, okay. So the 9700X is the 8-core there. So then, yeah, it actually would be... Okay, yeah, default TDP there is 65 watts. I didn't realize they were that low. I thought they were higher than that. Whereas the 9800 X3D is 120 watts. But still is, that's... This this different stacking is going to be enabling that kind of thermal design. So that's really interesting to see them do. Also, that does just show that AMD and TSMC, because they're the ones manufacturing it, are now having more experience manufacturing in that way. So you might see other things starting to do that. I'm not necessarily sure what, but like in theory, if you had... Because in laptops, you know, compact form factors like that, heat is even more important than in desktop. So maybe this could allow 3D V-Cache to come into laptop formats. I don't know, because also I'm trying to remember just how thick they are, because the laptops might be thinner, but there's a lot of silicon, inert silicon in every CPU to help it reach the IHS. That's part of the reason why delitting and lapping is a thing. I don't know how many people still do it, but yeah. I also just want to look. Is the so the 9950X is 170 watts compared to the 9900X that's just 120. Might be buying one of those before long, the 9950X. Not for myself, but my dad is retiring at the end of the year, and I think it's gonna kind of be a fun idea to build him a new computer. And it's also kind of funny that I may actually make it the most powerful computer in the house. I don't know, because my Threadripper is still... Nothing matches it for PCIe, and nothing's going to match it... Well, quad channel. I don't know how much something may be able to match it for total memory bandwidth. But, yeah. And... Can I give you a job yet? Can I, like, actually schedule you to do stuff? I don't even know if he's doing anything. I should add. I really don't. Yeah, I'm just gonna do that. Well, if you are... I mean, everybody can just wear whatever the hell they want. You need to figure it out, dudes and dudettes. But yeah, and just I could see him doing some video work, so that's why I think I want to give him the 16 core. And by the way, he does know this. And for anyone being like, well, why don't you get the 7950X? It's like, he's going from... I'm just trying to remember. I think it would have been Excavator? It's like he's got an APU in there, like a pre-Zeppelin, pre-Zen APU in there, okay? That's 4 cores. So this will be a huge leap, and it's like, why get the previous generation when I can just get him the latest? I get that I do understand the whole the 7000 series is not necessarily as large a leap from the 7000. I get that, and so some people are like, well, why would I upgrade? It's like, I don't know why you'd upgrade one generation to the next like that anyway. But it's why not just go to it? I mean, yeah, it may be save a little bit of money, but I mean, the money isn't so big a concern. So. But yeah, I think he will be doing some stuff, and the improved efficiency, I think it's slightly higher clock speed, will also be beneficial for him. So, but I could see him doing video work. I can see him doing some audio work, and also just that way he can do whatever the hell he wants. And I do think that, you know, that is a nice thing. You know, you should always, in my opinion, especially for CPU, overbuild. Always overbuild. It might only be a step above what you think you need, but, you know, do that because once you have something more powerful, you will start finding that, oh, I want even more power. And, yeah, there's nothing... That to me is just normal, so you can do that. Yeah, but I mean, it will be, and I'll probably end up, especially since Windows 10 is going to be losing support, and I'm not updating my desktop to Windows 11. I can't also, but I'm not going to. So yeah, I will do that eventually, but I want to keep the Threadripper. I just love knowing that I got all the PCIe lanes I will ever need. But yeah, that'll be fun, but that'll be a while longer, because also I'm running out of room. It's like I got the test system, the desktop, and the server, all that are in... I mean, the smallest case is the test system, and that's just an MA ATX case. The other two are full ATX cases. Technically, they're both mid-towers. The laptop, so I'm just like, where am I running out of space? And it is also, I'd want to... I've been carrying over the same install for my desktop for a few builds. I'd want to start new, so I'd also want to keep this running for a while, so I would need the room. Alright, that is why I had them focus the way I did. Okay, so, that being the case, there, that on, so these can hopefully keep growing. Just matured. Something just occurred to me. I actually do want to... Yeah, that's what I thought. See, this is another one of those, why are they giving us new features when there's so many obvious quality of life things that they need to be doing? For example, making a visual difference between summer and winter clothes, because there isn't. You can't look here, you have to read, you cannot look and see a difference with the icons. Also, the icons are really small. But it's like, you look here, and it's like, okay, is that in winter or summer? Is that winter or summer? That's summer, apparently. Summer. Oh, winter. Is there a difference here? No. Summer, winter, summer, and it's. I also am not entirely sure why they didn't do that. I mean, it's like, you know, you guys are just doing that. Nope. Yes, I'm just everybody. And it's still so stupid. I'm sorry, it is just stupid. This whole, that you can just tell them, basically, hey, get naked. I mean, it's like, what the hell is this? Yeah. But it's what they are doing. Like, it doesn't schedule for these changes to happen. It just does them. It's so weird. Trying to think what else. Because, I mean, that really seemed to be the only highlight of the week. What? Why would there just be someone close sitting? Oh wait, no, there would be someone close. But it's like, why are they? I literally set all those to be hauled away. Okay, what are you doing? No, you are doing that. One thing I saw that is kind of neat. I wish that the article were better written, which also reminds me of one thing I saw. But MIT, and I put this in the Friday write-up. MIT did some research. That was kind of neat, new transistor design, but I wish that they had explained one aspect of it better. And why are you upset? I don't know. I guess maybe just because he had a bad conversation with somebody. Deal with it. You're an adult, aren't you? I mean, I don't believe that there are any children, but yeah, you're 52. Come on. But yeah, so it was talking about how this MIT research was talking about how basically there is a fundamental limit to the minimum voltage for a silicon transistor to work. Unfortunately, I couldn't find anything really explaining why the Boltzmann tyranny is what it is. That's what it's called. And it has to do with thermodynamics, but it's like nothing beyond that. So I'm guess is what I could find. So I'm guessing it's something along the lines of it has to do with the ability to find vacancies for the electrons to fall into, and then also just the amount of energy it takes for the electrons to move around. And this is a fundamental limit such that no silicon transistors, or rather any traditional transistor, will have this limit. And there will never be anything we can do about that. It is not solvable directly. The MIT thing, and they do make reference to there being other examples of this. The MIT thing is with tunneling transistors. So instead of using traditional, I guess just traditional electricity, I guess is a way to put that. Instead, I guess in theory I should actually put down more of these right there. Yeah, just nobody's doing that. Okay, you know what? Fine, we'll do that. Tunneling is one mechanical phenomenon, and it's actually a pretty neat one. One thing that, as much as I do rag on this game, at least it does offer the handy thing of because everything is based on a grid, I can use it to draw things out. So basically, let's actually use this, since we saw wasn't last time, animals just walking through these. So, we can imagine that's tunneling, because the cow, because it was a cow as I recall, and a sheep. No, maybe it was a donkey and ass. I don't remember. But in any case, it was able, it shouldn't be able to go through this because this barrier is too tall. It shouldn't be able to just jump over. Right, that's what classical mechanics tells us. Quantum mechanics tells us that it's actually possible because everything is waveforms. And also, it technically means that nothing exists at a specific spot. There's just a probability it exists there. At least when it comes to particles that are in a quantum state. As opposed to being so large that they become classical. Okay, I'm getting complicated here. One of the issues in modern science, and this is a legit issue, is we don't know where the quantum ends and the classical begins. And you can, by the way, substitute classical with general relativity. Okay? Because technically classical mechanics is wrong. Right? I mean, it's like Newton's laws of physics are wrong. General relativity overwrites them. The thing is, at normal energies, normal speeds, things like that, Newton is completely correct. I mean, it's the approximations there are accurate. So if you just take general relativity and apply the speeds that we all exist at, you get Newton's laws. They simplify down. Relativity simplifies down to that. Okay, so I'm going to use the term classical, even though technically it's quantum and relativistic. We don't know how to unify them though, because like general relativity deals a lot with gravity. We don't understand how gravity functions at a quantum level. To the point that we're not even sure if it really exists there. I mean, at least that's the latest understanding I have. We don't know if it actually is there. But we know it exists at higher levels, and we don't know if it goes down there, and yeah, it's all kinds of weirdness. So, we're talking about particles that are definitely quantum, not classical. Because in classical, there's no way to go through this. In quantum, technically things exist as waves and particles, it's duality, but as waves and probabilities. So there might be a very high probability that if you observe the position of an object, of a particle, it exists here. Right? That might be the case. But there can technically be a non-zero chance it exists over here. Or here, if we use this one instead, so moving forward, that it actually exists over here. It would be a very low probability, but it does exist there. Now, where quantum tunneling gets really, really interesting is basically if the waveform pass on this side, where it just bounces against the barrier here and would go back. If it technically, like if you just drew it through, this is how I remember it, but that was like 15 years ago. If you drew, when I was started, if you drew the waveform through the barrier, if on the other side, it would basically match up with what it is over here, then there's actually a chance, a probability, a non-zero probability, that it will exist over here. So let's, instead of it being here, there's a probability, and I imagine it's in this spot instead of this one. But there's a chance that it can do that. And that's what quantum tunneling is, because it just seems to tunnel through the barrier. The thing is, and this is very important, it never exists within the barrier, okay? That it simply ceases to exist here and then exists over here. All right? I want to be clear on that, because I can believe that some people would think that, tunneling, you're like digging through. No. You are literally having it cease to exist in one place and exist in the other. Okay? Quantum mechanics can do some weird things like that. So with quantum tunneling, with these tunneling transistors, the idea is that since transistors, the whole point of them is that you can control the flow of electricity, the flow of electrons through them. And so that's how you can switch between on and off, 1 and 0. Okay? Thing that where the Boltzmann tyranny comes in is the slope from from. Oh no, those still haven't been built yet. Okay. The slope getting from, that actually should be one more. Whatever, it's fine. To get from one to the other, to get from 0 to 1. The steeper that is, and this is something that I wish they had explained better, the steeper that is, the less energy you need, which seems odd. But I guess it is because you have to, classically, you have to provide the energy to go up the entire slope. And that energy is taken both going horizontally and going vertically up the slope. I'm guessing that's how it works. Not entirely sure. But it still is. Ideally, the slope would be infinite. Okay, so that it would basically be a square wave, ideally. It's easy for me to think of some of these things in terms of waves. But yeah, so that would be ideal, and that, I guess, would take the minimum amount of energy. But Boltzmann tyranny comes into play. It's like, no, that's not how that works. There is a maximum slope. Because a steeper slope, and I associate that with being greater, the steeper slopes are better, but there's a maximum steepness, okay? According to Boltzmann tyranny. But with tunneling, now you can have a barrier that technically should mean it's not it would not be a conductor or a semiconductor, it's an insulator. Okay, technically it would kind of be that. You can have the barrier can be that. The materials they were talking about are still semiconductors, they were saying. And sounds right based on those the elements of reference. I know some of those are used for as semiconductors in other situations. But a completely insulating barrier, like what you would tunnel through, would obviously have a very steep curve then, very steep slope. So they came up with this tunneling transistor design that has that, so if the electrons tunnel through, you can control, just like with traditional silicon, how many go through or not, so that gives you a semiconductor, a transistor design there. So you still have the on-off design there, okay? I know I'm kind of bungling this, forgive me, but it is basically by using... Oh, well, yeah, that may actually work. So instead of it... Okay, in order to get... I guess a way to think of it is this. In order to get over this, you would need... even though this is relatively short, you would need a ladder. That's not a ladder, a stairway here. Okay, that's essentially what we're talking about with semiconductors. You need to pump the energy in so it gets up, and now that's a 1, whereas if it gets stopped, that's 0. Even though the barrier is only this tall, and that's kind of the thing with the Boltzmann thing, is that you can't make this super tall or else nobody can climb it. But technically, the taller it is, the less voltage you need. That I'm a little unclear about. I wish I'd seen that explained somewhere, but is what it is. With tunneling, though, it's basically, well, you don't need this at all, so Boltzmann tyranny doesn't apply, and you can just boop right through the wall. Now, tunneling transistors are not new. They were referencing that, yes, there are other designs. Okay, so then what makes this research special? It's another thing called quantum confinement. Because tunneling transistors, yes, they do exist, but they have a rather important problem. Okay, at 40s, this should not be snow covered. Anyway, so I'm just noticing that. The problem is... Okay. Tunneling doesn't necessarily support high currents. And you do actually need a high current, so that's a large number of electrons flowing. You do need that for higher performance, right? Well, what they came up with to solve that is basically making the nanowires that comprise these new transistors very tiny. Like the whole transistor design being like 6 nanometers in diameter. That is tiny. Okay? And it's worth noting that would be... So for a 3D transistor, they were saying they believe that's the smallest. I'm not sure how many transistors today are 3D. Like, I don't think, like the 9800X 3D, I don't think that's using 3D transistor. It might be using 2.5D, but a lot of transistors are 2D, and I think FinFETs are more like, 2.5D. Because it's like, yes, the structure is being made vertically as well, but it's not, I don't think it technically is 3D. But I don't know. I'm not sure about the exact designs there. But anyway. And there is also, the point I was getting at is, yes, they're saying 6 nanometer diameter. That's different from, because these CPUs are on TSMC's 4 nanometer process. It's not actually 4 nanometers, though. It's, if I remember correctly, it's supposed to be equivalent pitch. So pitch is a specific measurement for the distance between certain things within transistor design. And it does mean that even though they say 4 nanometer, it might actually be more like 8. It's just that it performs at a certain level. But it's also, they become marketing names. They've been marketing names for a while. And I think that change happened when they went from planar, which was completely 2D transistor designs, to FinFETs. Because FinFETs, though larger, were able to produce equivalent performance to smaller planar. And at that point, it all just went to marketing. Anyway, 6 nanometer design. Why is that specifically relevant? Why is the 6 nanometer design specifically relevant? Because at that smaller size, and there'd be features in them that are smaller still, you encounter what's called quantum confinement. Which, going back to the walls here, imagine if you had these walls adjacent to each other. Okay? These cows are kind of big. I mean, technically, yes, they only occupy one space, but they're kind of big. If I stuck it between these two, it wouldn't be happy. It would want to get out. That's what quantum confinement is. You put an electron in a spot that it can't really move, that increases the likelihood of it tunneling through. So by applying that, you can now encourage more tunneling, which therefore means you can get higher current, because you will have more electrons moving through. Yeah, it's that may sound like a lot, and it is, but it is also pretty clever. Now there is more work for them to do, like such as trying to come up with better ways of manufacturing, because at this scale, and the fact that size is specifically relevant, they need to have as little variance as possible across the device. Because even a 1 nanometer change, a 1 nanometer variance is enough to change the performance. So you can't have that. So that's something that they want to work on next. But also, and this is important, who provided part of the funding? Now, interestingly, they only stated one funding partner. There would be others, because it did say partly, but one of them was Intel. So, yeah, at least Intel is aware of this research at a high level. AMD at this point certainly would be, but AMD would be like, hey, TSMC, did you see this stuff? Yeah, isn't that cool? We'll look into it more. Okay. Or ASML, who actually manufactures the photolithography systems that TSMC and Intel would also be using. Yeah, but no, it is important work being done. I mean, I guess that's all I really have there. I said important, then I realized, wait, where am I going with this? Yeah, so it's definitely neat. I have no idea when any of this may be realized. It's also a certain reality about a lot of this technology that's seen like replacements for silicon replacements, electronics replacements, all that. A lot of it is we've been working on that shit for decades, and notice we still haven't realized it yet. We still don't have products using it yet. And that would be for multiple reasons. One is just silicon works. It's still working. We're still finding ways to get more performance out of it. And we're not at a crunch yet. And there's probably just still more and more work to try to do. The heck? The thing literally came over, picked up, and then dropped it. What? What? I am very confused now. Hang on. I don't care. Oh. Thank you. That's important. I had no idea this was full. Crap. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, right? There. Well, yes, that actually needs to stay high. No, I did not realize. I had no idea. I should also see about expanding this out that way. No, that way. But yeah, so as I was saying, I mean, there's a lot of stuff where it's like, it's kind of one of those funny things, especially when like I'm writing a science fiction story. Hey, I'm gonna lose the mouse here. I have the test system doing something and use the same, and you might also hear it a little bit. I use the same mouse between them, it's really nice having a wireless mouse that does both Bluetooth with a laptop and its own special connection that I can use to the test system. Yeah, I got some new DVDs, and I'm just pulling them off so I can put them onto the server. Fortunately, one of the boxes cases for the DVDs is really crushed. I've never seen one that bad. All the discs are so far been fine though, so that's good. But it's still been kind of weird. But yeah, and one tip for anyone wondering and who uses MakeMKV, I have found that what works really nice, especially if you do have the storage space, which I do. Hang on. Okay, there. It can sometimes take a little bit before the Bluetooth shows up. Do a backup, and because that way you pull off the entire disk, and if there's any issue, MakeMKV throws an error for you. So you will find that out very quickly. And then you can have MakeMKV open that backup, and you can have MakeMKV open the backup then, and then pull from that, and it'll go faster. So long as you got the storage space, it's really nice because that way you verify the integrity of the entire disk, not just the stuff you're pulling. And it can be a little easier, especially when it's like this is a TV series I'm pulling off. So that way, you know you have it all there, and you don't need to put the disc back in if you accidentally miss something or whatever. Hang on, I just realized. Okay. No. I'm like doing the chest on the other one. There. Okay. Oh, I totally missed that. Putting the floor down as well. There. 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 Alright. Wait, what? There shouldn't be food needing to go in here. Yeah. The hell? Food should be going there. Oh, that's animal feed. Okay. Yeah, I guess that makes sense. Then, I should actually build up an area in that basement area where I currently have the animals. For that storage. The animal feed storage. I should do that. Alright, mining unfortunately will need to stay high. I have no idea what would be the... I guess construction? Crafting? Okay. It's getting a little lost. Let's... What? Yeah, because I'd most likely expand this out going that way. Or down this way. I could also go that way. It's just a little awkward at the moment. So yeah, I'll put the storage in over here. Although I could do it this way. Got like that. But anyway, there. I do want it to. I want to put a door in. So. Plus, one issue is how deep can I go? Because I'm gonna need to brace things. But at least I can see from here. I should be able to put in a beam right there. I just don't know how far over I can go. I mean, it would be 4, 3, 2, 1. 4, 3, 2, 1, 2, 3, 4. Should actually be like this far I can go. Which is 1, 2, 3, 4, 5, 6. So it'll match over there. Okay. And now I'm just doing that so I know that those are the... Well, then actually I can save a little bit. Come on. Save a little bit by doing that. Okay. Gathering resources for construction. Good. That means they are working on this. I don't know if I can do stuff with the hay piles. Like putting those over there, but definitely the feed. Oh my god, I did not realize that the animal feed was... Okay, yeah, other things have a higher priority. Oh, fodder. Yes, right there. Can that store... No, it can't. That's interesting. Okay, so that has to be sitting out. That's actually super annoying. Why is it that way? I don't see why it's unreasonable that you can store food in these. Why can't you store animal fodder? That's very odd. Okay. There. Anyway, yeah, going back, because with the other technologies meant to replace silicons, I mean, obviously, yes, there's quantum computing, but that's never going to replace traditional electronics, let me be clear on that, because it serves too different a purpose. Yeah, I mean, it's... You would never run Crisis on a quantum computer, I think is one way to put it. But optical computers, optronics, plasmonics, photonic... Well, yeah, that's true. It would be photonics, not optical. Well, those would be optical, but not optronics. It would be photonics. And also hybrids of those. That kind of stuff has been worked on for quite a while. And they will eventually do that. But I think it's going to be more so okay, we can't go further with silicon. Now we'll do it. Because there is a weird paradox with a lot of this stuff. A lot of science and technology where... Ideally, you keep it in the lab as long as possible because that way you can refine it more and more and more, so when you need it, it's refined. But there's also the paradox that, well, no, when you actually get it into reality, and people are using it, so you have a very broad user base, and also more people manufacturing it as opposed to just building it in a lab, you can find far more ways to improve it. So it is one of those things where waiting to ship allows you to refine, but also the earlier you ship, the earlier you get more refinements. It's finding that balance is very difficult, and it's like this is pure speculation, but I absolutely believe that you would have people at AMD, Intel, Nvidia, that because they're doing these architecture designs, that have to decide, okay, this is where we mark a generation, but we can do that. If we keep trying to add stuff, it's feature creep. If we keep trying to add this stuff, I know, it's awesome, but if we don't keep trying to do that, we'll never ship these things. And it is also the whole, we ship it, and now it's like, oh, like, especially with pre-Tensor Core, AI was already getting popular on, and things like that on GPUs, and also blockchain kind of stuff on GPUs. So then we're like, oh, we never envisioned this. Okay, we'll start designing things to enable this. So yeah, I mean, that is in fact how that works. Like, getting it out there is important. And I remember I once wrote up a thing. I can probably still find the document, I'm just not sure where. And I could also probably just think it through again. I'm good on flax seeds, I think. That it would be fascinating to have in, okay, you know what, we're gonna do that. Well, okay, yes. Get rid of all the fine. Actually, no, get rid of all. Get rid of all. Because it's set to just make more. So somebody will go over and make more. Oh, and definitely the winter clothes, because they should be wearing those, so I have no need of any of these. Absolutely not. There's no way you can pay me enough, though. Okay, I'll keep the summer clothes, then. That will help. And I'm going to have to figure out other things to give me. They had animals. Those tend to be valuable. I can also take barley. How do I have such little barley? Yeah, I'm taking that. I thought they had animals. Whatever. Yeah, I'll take carrot seeds. I can actually take all that and it's still on. Okay. Oh. Hang on. 0. Flatten that out. You know what? Yeah, we'll just do it that way. I don't mind them getting a little bit of a benefit off me. I know I was talking. I got distracted with that. Oh, that's right. I once wrote something out thinking through, and this was years ago. I still remember a fair portion of it. The idea of having I was thinking of it like a space-based sports game. A tech tree that instead of working like this, with these very specific, it'd be nice if we could drag that open. These very specific things was like, oh, now you achieve agriculture or whatever, or better yet, the wood carving and such, or maces. Instead of it being more so specific, it's more like, no, you can just invest in your research into let's use warp as an example, into the warp drive. And you can continuously invest into that, and then you said, okay, now send it to manufacturing. So that then it's not a, hey, you've achieved warp 2. Hey, you've achieved, generation 2, generation 3. No. It's a, I've decided this is when I want Gen 2. This is when I want Gen 3. You decide that. And then you have that going. But then once it gets into the manufacturing, you start seeing refinements there. Where it might be smaller refinements. But it is I see, and this is also kind of funny. I think I mentioned this before. Actually, I should let that go. I have this thought that Moore's law is technically false. Not because the increase isn't exponential, but because the way it's the thing that's actually happening there is accidentally exponential. And I know a way to find out, I just don't know how to collect that data. So Moore's law says that the number of transistors doubles. The number of transistors you can pack into a certain spot will double every, 4 years? Is it 4 years now? I don't remember what the timeline is. I think that is actually incorrect. That's not that you have this exponential curve. It's that it's actually a logistics curve, so an S curve. But we just always end up getting to a new generation that it resets the curve. And so we've just had a bunch of logistics curves that have been lining up to approximate that specific doubling. That is my... What? Okay, I guess I was clicking on the person. And the way you could actually check this is with Intel, because they were stuck on technically the 14 nanometer for a while. Because wasn't it 14 nanometer and then they went to like 12 or am I thinking about what Global Foundries did? But that whole string of generations that they had where they just could not get to their 10 nanometer, if you look at that and start looking at their densities and performance, I think you may actually find that, yes, it's following a logistics curve in that it tops off after at a certain point, and there's no more improvements to be made. That it's as refined as possible. So that would then also be like integrate that into this tech tree design, where you need to realize, okay, have it go into manufacturing, because that will then allow you to get some more refinements, but then you can start on the next generation that resets the logistics curve. So you have to balance that to try to stay at the right spot on the slope continuously, but there can be advantages to waiting, because the longer you wait, the better the manufacturing will be. So that means you'll produce more quickly, fewer resources, or at least less cost. The whole 14 nanometer, there are still products made on 14 nanometers today. And they are made very efficiently, so there'd be very, very high, I'm blanking on the yield. Very high yield and a very low cost, right? So that's still definitely a thing. So there's a benefit to staying on an older generation, but that kind of intricacy of having it be, no, we're using the older part, that's not always achievable in video games. But it's like you could build that in where now manufacturing is doing that, they're making their refinements, so you're going from like 90% yield out of the lab to 98% yield, and kind of thing there. So you gain those benefits that can go back to the lab and help the lab. So that's a yes, get it. Well, that makes sense for a yes, leave it in the lab for a while, so you're getting more of those benefits. Then have it exit the lab and start a new generation, resets all that. So now the yields are down, costs are up, all that, but then give it time. I think that could be very interesting to try to do, especially because it technically would compel open-ended research. There. Very high, clear all. Well, animal feed fodder. No, actually, it can be both. Well, yeah. Because I don't need... Oh, wait. Hang on. No. There. I don't need them running over and, putting the hay in here. I just want the feed moved over. But yeah, I could. Man, I wish we could see a game do something like that, because I do think that is more realistic, and that the intricacies there of the different generations, I think players would find that interesting, would be able to find benefits to doing that. The question is, how much do you expose to the player? I'm completely serious. How much do you expose? Because you need to have like some sort of benchmarking so that you can plot out that curve, but you can't just tell somebody, hey, this is the optimal point in the curve. It's like, no, you need them to actually look at the data and decide that. Plus, you also want to put in their ability to the spontaneous discoveries, which some games have. Pax Imperia, which is... Oh, son of a bitch, that game's so old. I love it. It's a great game. It really is, but it is old. And I have a copy. It's on GOG. I think it might also be on Steam. Nope, just on GOG. October 1997 is when it originally released on Windows. Yeah, it's old, but there's a part of me that wants to replay it and do some recordings in it, because it is from a different era of games, and this I know I've talked about before, that I do believe that we are not in a great era of games at the moment, because we don't. When I've ranted on engines, this is the thing I'm getting to, game engines. that it used to be, like Pax Imperia would have been made on a custom engine that the developers built because they needed to. There was no such thing as Unity or Unreal Engine at the time. You had to just write it yourself. So you had to be an engineer, or at least you had to have engineers there to do the work. Today, so much of it, I think, is just being done by designers, essentially. And I'm not saying this to insult any designer. I don't mean that. Although there are some that deserve to be insulted because they're incompetent. Just like there would be some engineers that are incompetent. But what I mean is, the point I'm getting at is, because they're not engineers, they're not working with the engines, they're not in there, they're not experimenting with that, they don't know how it necessarily works. And you should be fine. That because of that, they can't be as inventive with what they're doing. Because, like, they're limited to just, hey, this is how tech tree works. I'll just pull up that module in Unreal Engine or in Unity in this case, and then go. It's like they can't come up with a new tech tree formula, a new system there, because they would need to be engineers, and they don't know that. Well, so they don't have the background to do it themselves, and they might also not have the background to think of it either. Because they don't even because some people, they wouldn't even realize that that's a possibility. And that is a sad truth, though. There is true that there's some things where if you just don't have enough of a mastery of something, you have no idea how to apply it and then expand on it. And even then, that's not even always the right way to put it. That it being about the mastery of it, because I'm just thinking, I've done some things like, I was actually looking at it not that long ago, the CPU thermal and GPU thermal applets I made so long ago now. I actually did some stuff in there that, according to the documentation for the R tools I was using, Shiny specifically, according to that documentation, what I did should not have even been possible. It should actually be not possible. But I found not only that they wrote something incorrectly in the documentation. They documented some. Well, yes, no. What they did was incorrect because they used the same name in two places, referring to very different things. But it was funny because when I mentioned that, and they were like, "Oh yeah, we'll fix that." And you know what? We should just drop this argument even being documented, because it doesn't matter. And I'm like, "No, keep that. I actually use that. Like, I found a way to do something that's actually very valuable, very useful to me." I never got a reply to that, but I don't think that they even fixed the error. I can try looking. I'm just trying to figure out it should be that. Mm-hmm. I want to make sure I look at the latest. I have no idea. They've completely changed this, and I don't know. Oh, there we go. References? Function reference? Oh, geez. Let me just... Here we go. They do still have that there. That's good. So it was the NS, the namespace function. ID is what they wanted to drop. It's funny that they say ID equals null by default, because I'm pretty sure that's not actually true. Oh, wait, no. I take that back. That is true. Have they ever updated? No, they haven't. So they still have the mistake, and this is now like at least a year old. Okay, so just quickly explain this and then I'll stop. To do modularizing, they suggest using namespaces, which the way it actually is functional, and this is what I broke to get things working, is a namespace. How it functions is basically just putting a prefix on a variable name. Technically, it's supposed to be then also cordoned off where everything in the namespace is separate from everything else, but it's like it's just a prefix on there is how it seems to actually be working. So the NS function takes two arguments, namespace and then an ID. An ID equals null. That is, by default, that's correct. Because what you do is you take the namespace function and you just give it the namespace name. Okay, whatever that is. Let's just say module. So NS, capital N, capital S, parentheses, module. You then store that to something else. So they use an example here of ns.sep, whatever that name is. That is now actually itself a function, which that ns module, and let's just say we save that to x. Okay, x is now a function that you give the ID to. So when you give it like variable y, x, and then in parentheses y is the argument, that now creates the y variable in that namespace, in that module namespace, okay? I know I'm not explaining this very well, but just bear with me. The NS function has two arguments, namespace and ID, okay? The second one is ID, the first one is namespace, and order does matter here. In their guide for how to modularize, the example they use, they show NS, well, they have a function, the way you make a module is you have to make it as a function, and they give the first argument for this larger function is ID. And ID is then what they pass into the NS function. So ID is being sent to the namespace argument in a function that also has an ID argument. I hate that they did this back then when I found it. That's why I reported it, and they have never fixed it since. That annoys the hell out of me. But it is still, I when I reported it, they were like, oh yeah, we'll just drop that ID thing there. It's like, no, I use that. Because I was pucing into the namespace. In those in the applets I made, I have graphs that are modular. So I can just change the inputs and get different versions of the graph for specifically different data. Temperature, frequency, power utilization, I think I had there, right? I wanted to be able to zoom in on one and then apply that to the others. In order to do that, I have to have a button that would reach in, grab the zooming, the left and right for the zoom, pull that out, and then force it into the other namespaces. In order to do that, I use the ID function here, the ID argument here, so that it knows where to send them. So it knows how to puce in and send it. So that actually, it's funny. It's like, this is actually really, really valuable. Now I'm trying to remember. I know... hang on. Isn't that simple? Okay, yes. I know I have it up on GitHub. On my GitHub. I want to check. Because I wrote up my own Shiny modularization guide. And I put it up in different places. Here it is. Our Shiny modularization. Okay, yes, and I do have namespace pucing in here, as I call it. Well, yeah, I can probably just leave that, but it's like, that's what I call it. Yeah, because I do have here then a function that will actually use the original NS, gives the namespace, that's something else, and then the ID has to be explicit, as I recall, but I know what those are. Those are easy enough, because in the different modules, it would be the same name there. The namespace is what changes. So that's all I need to pass. So yeah, I mean, it was awesome. But yeah, I wrote that guide. Okay, that was from 2022, so November 20th, 2022. So that's going to be 2 years old, and I would have reported that issue prior to that. Okay? Just to help give the larger context here, that they have not fixed that actually pretty serious documentation issue. Because if you're just reading that and you don't fully understand what's going on, you're like, okay, ID, there's the ID. Wait, why is that doing this? It doesn't make any sense. So, yeah, this is actually very frustrating to me that they've not changed that. But it was also, the point I was getting to is, because of my experimentation kind of craziness with the, okay, there. with the shiny modularization, I found stuff that not even like developers working on it directly, even thought of doing. So yes, even though my point that you can have people, well, that today you do have people that are just designers. They don't necessarily know how to invent. They don't necessarily have the tools there to do so. There's also people that, no, they are supposed to be the inventors who also don't think to do some of that. And I've done other things like that as well, where it's like, yeah, no one in the right mind would think to do this, but I have a need for it, so I did. Yeah. Sometimes it's just how it goes. But so long as in the end, I'm taking care of more stuff on the test system. So long as in the end it all works, that's kind of what matters. But yeah, and PAX Imperia is just one of those games where it is from a time when that's you had to know what you were doing. When it would be engineers making a game as opposed to designers today, and engineers, because they know the engine, they can get more out of it. And it's also like here another thing that's bit newer, but I think it was a single developer. The game Star Drive, which is another 4X space-based game. There's a feature in there that I would love to see Stardock incorporate into Sins of Solar Empire 2, since that's the current one. And that is, you could do fleet design in Star Drive, where you can actually plot out, okay, I want the destroyers here, I want the cruisers here. You can do that. That I don't necessarily care about. But the idea is that you could still have a fleet design where it's like, I want 10 destroyers. Well, no, it'd be more like 20 destroyers and 10 cruisers, right? If that goes into battle and you lose some of them, you can actually just hit a button to rebuild the fleet. And it's like, oh, okay, you lost 5 destroyers and you lost 3 cruisers. I will build 5 destroyers and 3 cruisers for you so it gets back up to where it was. I want that function. Why can't I have that function in other games? I don't necessarily need to have, like, okay, I want the destroyers positioned here, the cruisers here. I don't necessarily need that. But just say, hey, I lost this number specifically, rebuild those. And don't make it just like after you, I realize I'm just ranting now, sorry. Don't make it where it's like, hey, after the battle, this is, these are your losses. Would you like to rebuild? No. Let it be where you can do this at any point. Especially since in Sins, battles it's not like Galactic Civilization, where it's turn-based and technically battles take place within a single turn. Sins is real time, so you need that ability to just select a fleet and say, yes, rebuild these. You can select the fleet and then be like, hey, build 10 destroyers, but it's like, well, no, I just wanted to go back to its original strength in a single button press. Give us that! But I do think, as I recall, Star Drive was a single developer. So there would have been that element of, it's one dude doing everything. Doing the designing, but also the engineering. Whereas Stardock, and I'm not saying this as any kind of slight to them, except as a, come on, learn and do this. Play Star Drive, see that, and be like, oh, wow, that's neat. These other things, not so neat. We're not going to do those, but that's neat. But I do not doubt that they have the people there. That's just more of a, hey, can we do this? Yeah, I just never thought to do that. Cool, let's do it then. It kind of reminds me of a story so many years ago. The Marvel Heroes game that is defunct, which is a shame. David Brevik? I remember Brevik. I don't remember if the first name was David. He was like one of the head higher-ups of the company, and he was a producer. And some of the people that work there talked about how normally producers suck because they'll walk by your desk and just be like, hey, I want you to do this thing. And they have got no idea what they're actually asking. It's like, yeah, that's going to take me a week to do. And it's like the producer just wants it done. Not Brevik, though, because he actually was from that era of engineers being nerds that wanted to make games. So he was an engineer. And if he walked by and saw you work on that, he wouldn't just say, I want this done. He would say, and here's how I think we should do it. And he will sit down and work with them because he had that background. And it's like, that's what we need. Yeah, I hate the fact that Unreal Engine is taking over so much. And Unity, because it's just, it's supporting the whole, it's just designers, not engineers kind of thing. And we're just going to get to more just cookie cutter games. Which, don't get me wrong, there are plenty of cookie cutter games that are quite good. But it's more like variations on something, and some variations are good, some are bad. That's my point. Some good games are very good. But we need that innovation as well. And it's just, it seems like it's getting less and less common because Unreal Engine, Unity, and such are becoming so much more and more common. But hey, that's where indies come in, because plenty of indie devs, they are the engineers. They just want to make video games, so they're doing that, and they're making their own engines. Hopefully they end up getting the attention and support necessary to continue with that. So it's not just so we don't just have the situation of, oh, that's real, that's a neat game. It only sells a little bit, and the company ends up collapsing because like we need to feed our families and stuff like that. Anyway, that has been enough of my blathering, and see you next week.